Okay, and we're back with the second half of the Unit 2 review for Math 4. Picking up with number 11, we're going to identify the asymptotes, the holes, the intercepts, the whole 9 yards. So, first of all, we'll start with the fact that I have these guys that will cancel out. And so that tells me that I have a hole where x is -2. Remember, of course, to flip the sign from factor to solution, the sign changes like that. I have a vertical asymptote here, where x is 1. Now, as to a horizontal asymptote, I've got to realize that when I multiply this thing out, I'm going to have an x on top, and I'm going to have an x squared on the bottom, as far as my leading terms, the terms that define the degree of the thing. And so the rule says that if the boat is heavy on the bottom, it will float, but barely. And so that's going to be y equals 0 for a horizontal asymptote. Now, for the x-intercept, normally I would be looking at this x plus 2 on top and saying, oh, my x-intercept is -2. But there's already a hole there, which means life doesn't exist there. So I have nothing for my x-intercept. And if I were to multiply this out, let's just take this on out. I would have an x plus 2 on top. But when I multiply this out, I have the x times the x, which gives me the x squared. X times 2, which is 2x, -1 times x, which is -1x, plus 2x minus 1x, that's plus 1x. And then -1 times +2 is -2 at the end. Now, that is where we look for our key to the y-intercept. Where is the y-intercept? The y-intercept is where 2 over -2, or we could just simply say 0, -1 for a y-intercept. 2 over -2 being reduced down to -1. And you're always looking at those two constants at the end of the top and the bottom. What kind of a fraction do they make? In this case, it reduces down to a whole number, so life is good. Now, for this next guy, I am going to take this down to the bottom of the page, and we are going to factor this thing out. I'm going to show you down here. We had 3x squared minus 5x minus 12. And so normally, if I didn't have the 3 up front, then factoring this would be simply a case of, well, what two numbers, multiply to give me 12, but add to give me, or add or subtract to give me 5. But the 3 is in the way. And so here's the method that I've taught. Rather than guess and check, guess and check can be done, but it also can be time consuming. So I'm going to show you the direct way. We're going to take the 3 and multiply it to the back. So 3 times -12 is -36. Now, I realize I am breaking all sorts of rules of algebra by doing that. But I promise you we're going to put it back when we're done. And for some reason, it works. This is one of those things that, another one of those things that I intend to ask God when I get there, what was up with that? How did that work? So anyway, I don't know. Maybe if I dealt with more advanced math, maybe I would understand how it works. But for right now, it's magic. But it works. This is something we can do time and time and time again, and it works every time. Now, at this stage, we can play the what two numbers game. We can say what two factors of 36 would add or subtract to give me 5, and the answer would be 9 and 4. Now, I got to make the signs work here. I've figured out what the digits are. This 9 times 4 gives me 36. 9 minus 4 gives me 5, but I got to make the signs work because, first of all, I'm going to notice that the 9 is bigger than the 4, and I'm going to focus on him for a moment because whatever sign is going on in the middle, the minus 5x, that negative is also going to go with the larger of the two factors. That's going to happen every time. That's got to. Now, by the time I ask myself -9 times 4 gives me -36, he is going to have to be positive to make that happen. All right, so now I've got this thing factored. Now, here it's time to pay the piper. All right, we're going to take that 3 that we multiplied, and we're going to come down here, and we're going to divide both of them by 3. Okay, and I promise you it works. Now, we do have one other little trick that we have to pull here, because when I say -9 divided by 3, that is -3, no problem. But I really don't need a fraction in there. That is not going to work. And so this is where we do something that, for lack of anything better, I've heard it called bottoms up, where you take this and you put it up in front. You take the bottom of the fraction and you put it up in front. 3x plus 4. Because if I were to come over here and do this and solve it like a factor, I'd wind up with -4/3 for a solution, which if x plus 4/3 was the factor, then -4/3 should be the solution. So this is still, we haven't destroyed the equation any. But when I look at it, x times 3x gives me the 3x squared up front. X times 4 is 4x. -3 times 3x is -9x. -9x plus 4x gives me the -5x in the middle. And then the -3 times the 4 gives me the -12 on the end. So we have successfully factored this beast. And now we'll go back up and finish the problem. All right, so now we know how to break this up. We know that we get an x plus 3. Excuse me, that wasn't, my short-term memory is not what it used to be. X minus 3 and 3x plus 4. All right, that works. And then 3x plus 4. And then we can play the game on top. It is still a straight up, two numbers? 7 times 4 is 28. 7 minus 4 is 3. And if I have a -3x in the middle, then my biggest factor, which would be 7, is also going to share that sign. And if they're going to multiply to make a -28, then the other guy's got to be positive. Now, at this point, I can look at these and realize, nope, nobody's canceling. So I'm not going to have any holes. Vertical asymptote, I'm going to have 2 of them. I'm going to have x equals 3. And remember when we solved this and we got x equals -4/3? That's literally what you would be doing, is setting it equal to 0 and solving for x, and that's what it's going to be. And then there is the horizontal asymptote, that I've got an x squared here, I've got an x squared there. They match, which means I'm going to pay attention to the coefficients up front. I've got a 1/3, y equals 1/3, and that's going to be my horizontal asymptote. Now, when we start talking about x-intercept and y-intercept, I can look at the top, x minus 7, x plus 4. That is going to tell me where my x-intercepts are. Because x minus 7 means that I have a positive 7, and x plus 4 means I have a -4 for an x-intercept. And for my y-intercept, I look at the 28 and the 12, -28 over -12. Negative over negative is positive, they cancel, and the 28 and the 12, the 4 will go into both of those. Whoops, I didn't mean to put the negative there. 4 goes into 28, 4 goes into 12, and so my y-intercept is going to be 7/3. And it's okay to leave a fraction like that. At least you don't have to graph it. So that's what that should look like. And you will have one of those on the test. Now this guy, we get to graph another piecewise. I will start with blue at the top. Now this guy, absolute value of x normally goes like that and like that, but this is negative absolute value, which means that he is going down. Now, this guy going down like that and like that. But wait a minute, we only need everything from -4 and below. And -1, -2, -3, -4 and below. This is actually all we need. And we can get rid of the rest. So that's the first chunk. Now the next chunk, y is 1, which means we're going to come up here to where y is 1. And we're going to start over here at -4 with an open circle. And we're going to go all the way up to +2 with a closed circle. And we're going to connect the two. Sometimes I like it easier that way, that, if I can find where the beginning is, find where the end is, and just connect them. Usually it's a lot easier to graph these things. And then we move on to the third chunk, which is x minus 2 quantity squared. Now, if the 2 is on the inside like that, that means we're shifting left and right. Because it's -2, that means we're going to go 2 to the right. Our vertex is going to sit there instead of the origin. And we're going to play the game of over 1, up 1, over 2, up 4, and so on. And we would mirror around the other side, except we realize that we need an open circle at 2. And then we're going to kind of head to the right. So I'm going to change that to an open circle. And we are going to go up and away. And that is what our graph should look like. Now, what's going to happen in the test is that, I think I've designed most of this multiple choice. So you're going to have 4 different graphs to look at and see which one of them did they get it right. You'll be given the one equation over here, the piecewise function, and then you give 4 different graphs to see which one got it right. All right, here we are to this guy. We are evaluating f of g of -3, and of course f of g is the curve, or f of x is the curve, and g of x is the straight line. So if we're starting with g of -3, we're going to ask, where is x -3 on the g line? And that's going to be -3 and 1. So that means that it becomes a 1, and then we're going to take the 1 and we're going to plug it into the f function and figure out what happens when x is 1 on the f curve. X is 1, +1 right there. He is 1 and -1. So that means that my final answer is -1. Now, I'm going to clear those two because we have 2 problems here and we're kind of need a clear playing field for the other one. So we're going to figure out what is f of 0. So on the f curve, when x is 0, it is right there, which is 0, -2. I just can't draw a 2 today, can I? All right, and then we're going to say -2. We're going to plug it into the g function, which is the straight line. Straight line, when x is -2, g is right there. And the y value is 2. So that is how you do that. You find the guy on the right goes first, and then you plug him back into the guy on the left. Okay. Now for these, we are simply substituting in the algebra chunks. Here we have x plus 2 added to 4x squared, and you probably would find them in standard order, like that, x squared, x to the 1, no x. Here you've got f of x on top, you've got h of x on the bottom, And I hope somebody realizes that you can factor the guy on the bottom into something that seems to be related to the top. Yes, indeed. I can cancel out that and that, which means that my answer is 1 left over 3. And then for the last one, I say x plus 2 times 4x squared. That means I'm going to distribute this guy here and here. And I'm going to wind up with 4x cubed plus 8x squared. All right, for these guys, g of -4, I'm going to start with the first g of -4 on the right, and I'm going to plug him in. I'm going to get 4 times -4 squared, which is 4 times 16, which is 64. And then I'm going to turn around and plug it into g again. This time it is 4 times 64 squared, which is 4 times 40, 96, which is 16, 36, 384. Okay. Here we're going to start with h of 0 rather. 3 times 0 plus 6 equals 6. And we're going to plug it into g of 6, which is 4 times 6 squared, 4 times 36, which is 144. Okay. Then for the last one, we start with h of -2, which is 3 times -2 plus 6, which -6 plus 6 makes 0. So then we take that 0 and stuff it into g. G is 4 times x squared, 4 times 0 squared, which 0 squared is 0. 4 times 0 makes 0. Well, this is kind of getting easy, quick. And then the last one is x plus 2, 0 plus 2, which is plain old 2. Now, this one, we are going to have to use the Desmos. Well, I mean, you can plug it in. You can find your, well, you're going to have to use Desmos to get the equation anyway. You could use the TI-84. But it's the projecting when it's 75 that Desmos is so much easier to work with. Okay, I've moved Desmos to where we can work with it some. I actually have it left over from another problem, and I have the quadratic still there. This time we're supposed to look at both the linear and the quadratic and make a decision. So let's type in what we got. And oh, maybe this was the same numbers. All right, so that is our numbers, and this is our quadratic. And then this y sub 1 tilde mx sub 1 plus b. All right, so if we are looking at these guys in Desmos, r squared for the quadratic is 0.97. R squared for the linear is 0.3266. I mean, I'll drag this over here. That's a look at what the difference is between the two. So yeah, points are almost dead on the parabola, and decidedly not so with the line. So, all right, we're going to, well, I got to have the equation. All right, the best fit we're going to write is the quadratic. And the equation is going to be, I'm looking over here at the quadratic on Desmos. I've got a negative 0.02 x squared. And then my b is 1.465. We'll call that plus 1.47 x. And then I got plus 18. All right, that much was easy. Now, I need to figure out where x is 75. So I'm going to drag this back over here. And we're going to drag this down here until we see a 75. There is 75 at 7.393. When x is 75, y is 7.393. All right, 7.393. So, it's 7.393, but I look at all of these y's on the table, and they're all whole numbers. So I think I'm just going to call it 7. I'm going to acknowledge that I'm rounding this, but that's where I'm going to leave my final answer. It's going to be a little more than 7, but it's 7. All right, there's the graph of the parabola and such. Now, let's go back to this guy, because we need to talk about scatter plots. This would be considered strong positive. This would be considered weak positive. This would be considered weak negative, because it's going downhill, negative slope. And this would be a strong negative correlation. And so I'm going to give you a drawing much like one of those, and I'm going to ask you which one of these descriptions fits it best. Now they said suggest a likely R value. If this is going uphill, then we might say 0.9. If this is weak and going uphill, then we might say 0.2. If this is weak coming downhill, we might say negative 0.2. And if it is strong coming downhill, we might say negative 0.9. Something like that. All right, now we need to bring back what we're doing on the chart, because we now have a new chart to mess with. Okay, so I'm going to back up. We're going to go 20, 25, 35, 43. And we're going to go 2,000, 2,500, 5,000, 7,800. And these are temperatures and ice cream sales. All right. Now, the question says use the R-squared values to determine whether or not the best fit is linear or quadratic. As we expect, the quadratic is a much better fit. So we're going to say, well, quadratic R-squared is 0.9993. Doesn't get a whole lot better than that. And for the equation, we're going to say y equals 7.088. We might as well say 7.09 x squared minus 191.228. That would be 23x. And then plus 2941.81. And that's what your equation is going to look like. Now, they said project the temperature x when sales y is 6,000. So we are going to bring this back, and we are going to zoom out so we can see the thousands. And so when y is 6,000, actually that's 10,000 and 5,000, so 6,000 should be this line right here. And so I'm going to scroll in until I see them separate, because apparently they are right close to each other. Look at that. That is how close they were together. Now, if I ever get lost with this, I can always pull this up and realize that the black line is the quadratic and the red line is the linear. So I'm looking at the black line and saying, what happens when y reaches 6,000? 6,000.017. I don't think I'm going to get much better than that. No, well, that's like 0.3 away, and that's 0.01 away. That's as good as it gets. So 38,257. That's what the x value is going to look like. 38,257. So, and I will jot that down before I forget it. 38,257. Now, we need to look at the chart and realize the chart, all of the x's are in whole numbers. So, we would probably say something like this. It's about 38 degrees when you're going to sell 6,000 units. And of course, I've got the graph of that. Now let's blow this up. That's what the whole thing looks like. And we are done.